When you look up at the night sky, what do you see? The moon, a few bright stars, maybe a blinking airplane. But the naked eye shows us almost nothing of what's really out there. The telescope is humanity's answer to the question, what else is up there? Today, I'll tell you how a simple tube of glass became our window to the birth of the universe. In the early 1600s, Dutch spectacle maker Hans Lippershey combined lenses to magnify distant objects, mainly for military spotting. No one guessed this little spyglass would change the human view of the cosmos. Word spread. In Italy, a curious, stubborn scientist heard about it, built his own, improved it, and turned it toward the heavens, Galileo Galilei. Galileo did something obvious, and revolutionary. He looked. The moon wasn't smooth, it was scarred with craters and mountains. Around Jupiter he saw tiny lights that shifted night after night, moons in orbit. If everything circled Earth, how could that be? Galileo's observations supported Copernicus. The Sun, not Earth, was the center of planetary motion. Dangerous words at the time. The telescope had become not just an optical tool, but an instrument that challenged authority. After Galileo, the telescope arms race began. Johannes Kepler redesigned the lens layout for wider fields and better magnification. Then Isaac Newton stepped in. Refracting telescopes suffered from color fringing. Newton used mirrors instead of large glass lenses, creating the reflecting telescope and setting the stage for truly large light buckets. By the late 1700s and 1800s, William Herschel was grinding giant mirrors by hand and sweeping the skies. He discovered Uranus, expanding the known solar system. His deep surveys raised new questions. How many stars fill the Milky Way? What structures lie beyond? Huge refractors came next. The 40-inch at Yerkes became legendary. But the real leap came with big reflectors at Mount Wilson and later Palomar. Using the 100-inch Hooker telescope, Edwin Hubble showed that Andromeda was not a nebula within the Milky Way, but an entire separate galaxy. The size of the universe exploded in our minds. Then came another shock. Those galaxies are moving away. The universe is expanding. Astronomers soon had a new idea: put a telescope above the atmosphere. Earth's air blurs images and blocks many wavelengths. In 1990, the Hubble Space Telescope launched. It had a mirror flaw at first, but once repaired it gave us iconic images, none more famous than the Hubble Deep Field. A pinprick of sky, filled with thousands of galaxies. The universe is crowded, far beyond what anyone imagined. Hubble didn't act alone for long. Chandra, X-ray, Spitzer, infrared, Fermi, gamma, and others showed that the universe looks different in every wavelength. One telescope is like seeing in a single color. Multi-wavelength astronomy is a full-spectrum portrait of reality. On the ground, technology fought back. Adaptive optics measures atmospheric distortion and corrects mirror shapes in real time, giving near-space clarity from Earth. Giant observatories in the Chilean desert, like the Very Large Telescope, and the under-construction Extremely Large Telescope, pair massive mirrors with computing power to peel away the blur of air. Another revolution came from radio astronomy. In the 1930s, Carl Jansky detected radio noise from the Milky Way. Grote Reber built the first dedicated radio dish. Radio telescopes revealed our galaxy's structure, pulsars, cosmic background radiation, and wild phenomena around neutron stars. Colossal dishes such as Arecibo, now lost, fast in China, and arrays like the VLA gave us ears to the universe. Fast forward, the James Webb Space Telescope opened a new era in infrared astronomy. Its unfolding mirror and sunshield now let us study the earliest galaxies, infant stars in dusty nurseries, and the atmospheres of distant exoplanets. Webb's data is already reshaping timelines of early cosmic structure. And the future is loading. The Nancy Grace Roman Space Telescope is being built to survey huge swaths of sky, probing dark energy and hunting exoplanets statistically. On Earth, Mega telescopes like the ELT aim to resolve exoplanets directly, weigh black holes, and map galaxies in unprecedented detail. All of this began with a question. What's out there? You can ask the same question from your balcony. With a small backyard telescope you can see lunar craters, Jupiter's moons, Saturn's rings. Just like Galileo, but with better gear. The line between professional discovery and amateur wonder is thinner than you think. Every kid who points a telescope skyward might become the next great astronomer. Thinking about getting a telescope? Start simple. Binoculars for the moon and bright planets, or an entry-level Dobsonian to dive into deep sky objects. Tell me your budget and what you want to see, I'll help you choose. If this story inspired you, let's keep exploring the sky together. Subscribe, drop a comment with the target you want next, and maybe we'll tune the telescope for you in the next video. The universe is waiting, just look.